Today we're going to continue on in a new section of our book. It's Packet Module 3, Dining, Dancing, and Driving, and it begins on page 325. So let's make a note that we're on page 325. And we've been working on finding rate of change or slope from our graphs. You've been doing really good work on that. And then we worked on tables, and we talked about how to find rate of change. Remember, change in y over change in x, so that we can determine how a situation is changing. Today we're going to continue, but we are going to be looking at linear relationship in context. And what we mean by that is kind of real world situations. We're going to take a look at problems that could occur in everyday life and see what their rate of change is. And we're going to be looking for unit rates, which we all need practice on that. So let's go ahead and start on page 325. But to be honest, we're not going to work there. We're going to skip all the way to page 329. So turn in your packet until you get to page 329. It's going to be activity 3.2, determining slope from context. All right, so here we are on page 329. And you can see no tables, no graphs. We're reading problems. So we're looking at situations in context. It says, for each context, complete each task. Identify the independent and dependent quantities. And hopefully you remember how important that is. We said our independent variable goes on our x-axis and our dependent variable goes on our y-axis. And it's important that we keep those two straight. Then it says to write ordered pairs of 2 points that you can use to answer the question. Explain what each of the ordered pair means in your terms of your situation. And then determine the rate. Determine the rate described. And we're good at this. We can do this. Let's start with this first problem. Bella's Pizza Shop. Bella's Pizza Shop charged $4.50 for a small pizza, $7 for a medium pizza, and $9 for a large pizza. Toppings cost extra, okay, depending on the size of the pizza ordered. Bruce ordered a large pizza, so we know we have a large pizza that we're dealing with, and that he had 3 toppings on it. Now we know that if Bruce bought just a large pizza with no extra toppings, it was $9. When he added 3 toppings, the cost came to $12.60. So hopefully you can see the cost of the pizza depends on how many toppings have been added. So let's write that down. The cost depends on the number of toppings. All right, the cost depends on the number of toppings. And it says let's make points, but I think it's easier sometimes for us to see it in a table. These are still points, but this is how we're going to write them. And I want you to write with me and make sure you make a nice table. Since cost depends on toppings, I know that toppings is my dependent variable. So I'm going to put it on the right. I'm going to say this is cost. And you know what else I'm going to do? I'm going to put a y in parentheses to make sure you realize this is my dependent variable. And then I'm going to put number of toppings over on the left. And this would be on my x-axis. So I'm going to put a little x next to it. And then we're going to record what we know. We know if he buys a large pizza with 0 extra toppings, it still costs $9. If he adds 3 toppings, the cost increases to $12.60. Hopefully you now see something that looks very familiar. We know how to find the rate of change from a table. We have to find the change in y, remember our little symbol that we use, over the change in x. So I'm going to draw arrows here and say, I know I went from $9 to $12.60 on cost. So I'm going to find out how much of an increase that is. $12.60 minus $9, that is $3.60. Over on the number of toppings there, I went from 0 to 3. Well, that's an increase, obviously, of 3 toppings. So it costs $3.60 for 3 toppings. And this is very helpful because my question says, what is the cost per number of toppings for a large pizza? Well, let's find our unit rate. Remember, a unit rate has a 1 in the denominator. So if I divide 360 by 3, I get $1.20 over 1. This is my unit rate, and I can tell that the cost per topping is $1.20 for each topping. All right. Now, when you have context like this, you do need to have a way to organize your thoughts, and I think this is a very helpful way to do it. So this is what we're going to practice. We're going to practice this. All right, now that you kind of know where we're going, I'm going to skip 2, and I want you to look at problem 3. I want you to read it. I want you to determine the dependent variable and the independent variable, and see if you can pick 2 points that we can put in our table. And then come back after you pause my video, after you've done that, come back and let's see how you did. Well, let's see. Melanie is baking breakfast rolls for a band camp fundraiser. She bakes 15 dozen breakfast rolls in 3 hours. After 8 hours, she baked 40 dozen breakfast rolls. At what rate does Melanie bake breakfast rolls each hour? Well, hopefully we can see that the number of rolls depends on the number of hours. And rather than leave these in dozens, I'm going to multiply and find out how many rolls we're actually dealing with. Hopefully you can remember that 1 dozen equals 12 rolls. So if I have 15 dozen rolls, 15 times 12 would equal 180. And if I have 40 dozen, 40 times 12 is 480. We're talking lots of rolls here. So we know that rolls depends on number of hours. So I'm going to make my table with number of rolls for my y variable. And then I'm going to have hours for my x variable. And I know that in 3 hours, I can make 180 rolls. And after 8 hours, I have made 480 rolls. So when you found your change in y over your change in x, we can see we went from 180 to 480, which is an increase of 300. And then over here, I went from 3 hours to 8 hours, which is an increase of 5 hours. Once again, I'm looking for a unit rate. So I want a 1 in the denominator. If I divide 5 by 5 to get 1, I have to divide 300 by 5, and I get 60. So this tells me that I can make 60 rolls in 1 hour. Okay, so that is our unit rate. All right, now we're on page 330. And you've seen a couple of examples worked. I want you to try to do this one by yourself. It's not complicated. You're going to read the problem, decide which variable depends upon the other one, pick 2 points, and make a table. Then you're going to find the rate of change, and then you're going to give me a unit rate. Remember, a unit rate is where the denominator is 1. So pause my video and then come back and check your work. Okay, let's see how you did. First of all, the dog is losing weight. So we know that after 8 weeks, the dog weighs 149 pounds. After 13 weeks, he weighs 134 pounds. So he is losing weight. So our points are 8 and 149, 13 and 134. And we know that the amount of weight the dog loses depends on the number of weeks that they have him on this diet. So pounds depends on weeks. So we find our change in y and our change in x and we find out that it's negative 15 over 5, and that simplifies to negative 3 over 1. That would be our unit rate for our rate of change. So we can conclude that the dog Bull lost 3 pounds per week. Hopefully this makes sense to you. Okay, let's join me for our last two problems, problems 6 and 7. You've had practice now, and we've explained several. So I want you to try to work these on your own. So really pause my video and try to do it on your own. Read the problem, decide what the dependent variable is and the independent variable, make a table, find the change in y over the change in x, and then find a unit rate, and you'll have your answer. Try, do your best. I hope you did a good job on this. Let's review. You can look at my work while I'm talking. We know that the miles that Eddie travels will depend on how many hours he's driving. So my dependent variable is miles and my independent variable is number of hours. We know that after 4 hours, the miles on his odometer register 34,567. So that's 1 point. After 7 hours, the miles read 34,741. So that's our other point. So I find my change in y over my change in x by subtracting the numbers. So I find out that my change in y is 174 miles, and my change in hours would be 3. So he can go 174 miles in 3 hours. So when I find my unit rate, it tells me that he must be traveling at 58 miles every hour. So I'll say Eddie's rate is 58 miles per hour. On problem 7, Julie is using a gift card to buy her friends tea. So she goes to the shop and she has 5 friends. So altogether there's 6 of them. After she and one of her friends places an order, the balance on the card is $14.85. Well, Julie and one of her friends, that means that would be 2 people. So she bought 2 glasses of tea, and the balance is $14.85. So that's our first point. The second point is it says after all 6 members of the group got their iced tea, she had a balance of $3.97. So after 6 iced teas have been purchased, the balance is down to $3.97. So that's my other point. So when we find our change in y, we would subtract $3.97 minus $14.85. So that's a decrease of $10.88. It means she's used $10.88. That's why it's negative. She purchased 4 iced teas with that amount of money. And so our unit rate when we divide would be a negative $2.72. It doesn't mean she has a negative balance on the card. It means she's used $2.72 every time she bought a glass of tea. So we can assume the cost of a glass of tea is $2.72. I hope working these problems helped. These are really valuable. You have to learn to take context and try to come up with a mathematical representation. In other words, find the rate of change. So hopefully this will help, and we'll continue with this tomorrow.